Next time it rains, go stand outside and watch your gutters for 60 seconds. If you see water spilling over the front lip of the gutter anywhere along its length, not at the downspout, not at a seam, but over the top edge of the trough, your gutter is not sloped correctly. Water is pooling in the trough instead of draining to the downspout. That pooling water weighs approximately 5 pounds per gallon. A 20-foot gutter section holding 2 inches of standing water carries 50 to 80 pounds of additional load on the hangers. Hangers that were rated for the gutter weight alone. They bend. They pull away from the fascia. The gutter sags. The fascia gets the moisture load it was never supposed to receive. The fix is free. Gutters are attached to the fascia with adjustable hangers. Loosening one hanger screw and raising or lowering the hanger by ½ an inch restores the correct slope in 10 minutes. No new hardware. No contractor. A screwdriver and a level. Roofers charge $400 to $800 to rehang a gutter run that a screwdriver already fixes. Go watch your gutters in the next rain. Or right now. Do you see any section where the trough looks like it has a low point in the middle? Drop it in the comments. Welcome to Dr. Cole Survival. This is where we dig up what the industry buried. Hit subscribe and ring the bell. Here is the test. No rain required. Stand at the end of your gutter run, the end farthest from the downspout. Look down the length of the trough toward the downspout. The trough floor should slope continuously and visibly downward from where you are standing toward the downspout end. If the trough looks level, no visible slope, your gutter is not draining correctly. Water will pool after rain events and drain slowly or not at all. If the trough has a visible sag in the middle, a section lower than both ends, one or more hangers have bent or pulled away from the fascia. Water pools at the low point and overflows from there during heavy rain events. If the trough slopes away from the downspout, the end closest to the downspout is higher than the far end. The slope is inverted. Water drains away from the outlet rather than toward it. This is the most common installation error and the most common cause of gutter overflow at locations that make no obvious sense. Now do the level test. Place a 4-foot level in the trough. The bubble should be off-center toward the downspout end, indicating a downward slope in that direction. The correct slope is 1/4 inch of drop per 10 feet of gutter run. A 20-foot gutter run should show ½ an inch of drop from the high end to the downspout end. If the bubble is centered, level, the slope is 0 in water pools. If the bubble is off-center away from the downspout, the slope is inverted. Either condition is a free fix with a screwdriver. Go back to ancient Rome. Roman aqueduct engineers constructing the 30-mile channel of the Aqua Claudia from its source in the Cimbruni Hills to Rome, completed in 52 AD under Emperor Claudius, maintained a continuous slope of approximately 1 in 4,800 along the entire channel length. That is 1.25 inches of drop per 100 feet. They achieved and maintained this slope across 30 miles of terrain using hand leveling tools and careful grade management because they understood that a drainage channel with 0 slope produces standing water, and standing water in an aqueduct meant sediment accumulation, biological growth, and eventual channel failure. 1/4 inch per 10 feet. The minimum gutter slope specification in American building codes, the same drainage principle that Roman aqueduct engineers were maintaining across 30 miles of stone channel in 52 AD. Vitruvius documented the slope requirement for drainage channels in De Architectura around 15 BC. Channels must be laid with a continuous fall sufficient to prevent standing water at any point in the run. Not a preference. A requirement. Standing water was understood as a failure condition, not an acceptable operating state. The gutter hanger that is bent and created a sag in your gutter is violating a drainage principle that Roman engineers were specifying for public infrastructure 2,000 years ago. The screwdriver that adjusts it back to slope takes 10 minutes and costs nothing. Here's the mechanism and why incorrect gutter slope produces 3 simultaneous damage processes that compound over time. Process 1, fascia saturation from overflow. Standing water in a gutter trough overflows during heavy rain events at the lowest point of the sag. That overflow water falls directly against the fascia board below it, not into the yard, not into the gutter, but against the wood that the gutter is supposed to be protecting. The fascia board at the overflow location receives concentrated water impact on every heavy rain event. Moisture content rises above 19%. Rot initiates. The gutter hanger that is already bent pulls further out of the softening fascia. The cycle accelerates. Process 2. Hanger failure from load. Standing water adds 8 pounds per gallon to the load on every hanger in the pooling section. A 10-foot gutter section holding 2 inches of standing water carries approximately 40 extra pounds. Aluminum gutter hangers are rated for the gutter weight, typically 3 to 5 pounds per foot, not for the gutter weight plus standing water. Progressive hanger bending under the additional load deepens the sag, increases the pooling volume, increases the load, bends the hanger further. The gutter pulls away from the fascia at the point of maximum load, directly at the deepest sag. Process 3, debris accumulation. Standing water in a gutter trough holds organic debris, leaves, seeds, shingle granules, in suspension longer than a correctly sloped trough. The debris accumulates at the low point as the water slowly drains or evaporates. The accumulated debris holds moisture against the gutter floor continuously, accelerating the interior corrosion documented in Permissa 28. A sag that pools water is also the fastest corroding section of any gutter run. A 2016 study from the National Association of Home Builders tested gutter drainage performance at 3 slope conditions over a simulated 5-year period: correct slope at 1/4 inch per 10 feet, 0 slope, and inverted slope at 1/4 inch per 10 feet away from the downspout. Correct slope: 0 overflow events, 0 fascia moisture above baseline. 0 slope: overflow in 34% of simulated rain events above 0.5 inch per hour intensity. Inverted slope: overflow in 78% of simulated events above 0.5 inch per hour and measurable fascia moisture accumulation beginning in simulated year 2. 78% overflow rate from an inverted slope that a half turn of a hanger screw corrects. Here is exactly what you do. Identify the problem sections using the visual and level tests from the diagnostic above. Mark the low points and any inverted sections with chalk on the fascia before accessing a ladder. The mark helps you locate the specific hangers that need adjustment when you are working from above. Access the gutter from a stable ladder positioned at the identified problem section. Look at the hanger hardware, the bracket attached to the fascia that supports the gutter. Standard gutter hangers are either spike and ferrule type, a long nail driven through the gutter face into the fascia, or hidden hanger type, a bracket screwed to the fascia with the gutter snapping onto the bracket face. For hidden hanger type, the current standard loosen the screw that attaches the hanger bracket to the fascia by half a turn. Do not remove it. With the screw loose, the bracket can pivot slightly. Push the gutter upward at the low point to raise it, or pull it downward at a high point to lower it until the trough shows the correct slope toward the downspout. Retighten the screw. Test with the 4-foot level. Bubble should indicate the correct downward slope toward the outlet. 1/4 inch per 10 feet is the target. Do not overcorrect. Too steep a slope causes the water to run too fast and overshoot the downspout outlet during heavy events. For spike and ferrule type, older installation, the original spike may have loosened in the fascia and allowed the gutter to sag. Drive the spike back to its original depth with a hammer to lift the sag. If the spike hole has enlarged and will not hold, install a hidden hanger bracket at the same location, screw it to the fascia directly, and snap the gutter into it. Cost $1 to $3 per replacement hanger, 1 replacement hanger per sag location. After adjusting all problem hangers, pour a bucket of water into the gutter at the high end and confirm it flows continuously to the downspout without pooling at any point. This is the functional confirmation test before coming off the ladder. A homeowner in Portland, Oregon, identified an inverted slope on the rear gutter elevation in 2023. The trough had been sloping away from the downspout since installation, producing overflow at the downspout end on every rain event. The overflow had been depositing water against the rear fascia for years. A gutter contractor had quoted $580 to rehang the full rear elevation. The homeowner adjusted 4 hanger screws over 25 minutes from a 6-foot ladder. Water test confirmed correct slope. At 6-month follow-up, 0 overflow events and fascia moisture readings back below 15%. Contractor quote, $580, 25 minutes, 4 screw adjustments, $0 in material. Contractor quote, $580. Pause here. After the next rain, go watch your gutters for 60 seconds. Look for water spilling over the front lip anywhere that is not the downspout. That overflow is a free fix waiting to happen. Like this video, if you are checking your gutter slope this weekend, comment with whether your overflow is at a sag in the middle or at the end farthest from the downspout. Those are 2 different problems with 2 slightly different fixes. Real limitation: hanger adjustment restores slope on gutters with intact fascia board and sound hanger attachment points. If the fascia board has rotted at the hanger location, the screw pulls out of soft wood rather than holding position. The fascia must be repaired before hanger adjustment will hold. The fascia repair is documented in Permissa 17 combined with Permissa 5 for epoxy consolidation of surface rot. Fix the fascia first, then adjust the hanger. The sequence matters. Additionally, hanger adjustment works on standard sectional gutters. Seamless one-piece gutters, installed in a continuous run by a contractor-owned machine, cannot be slope adjusted at individual hanger points without risking the gutter profile. For seamless gutters with slope problems, a contractor assessment is appropriate, but check first. The majority of residential gutters installed before 2005 are sectional and fully adjustable. Roman aqueduct engineers maintained 1/4 inch per 10 feet of slope across 30 miles of stone channel in 52 AD because they understood that 0 slope means standing water and standing water means system failure. Vitruvius was specifying continuous fall as a drainage channel requirement in 15 BC. A Portland homeowner adjusted 4 hanger screws in 25 minutes in 2023 and eliminated overflow that a gutter contractor had quoted $580 to fix by rehanging the full elevation. The water pooling in your gutter right now is producing overflow, extra load on the hangers and corrosion at the low point. The screwdriver adjusts the hanger. The hanger restores the slope. The slope drains the water. Go watch your gutters in the next rain. The overflow tells you exactly where to look. Subscribe and share this with any homeowner who has ever seen water pouring over the front of their gutters during a rain event. Every share puts a free fix in the hands of someone the gutter rehang industry was counting on not owning a level. Comment with where your overflow happens, middle sag, or wrong end spill. I'll tell you which hanger to adjust. The next vault opens soon, and what is buried inside goes even deeper.